Hi everybody. In this question, we're told that fresh Bing cherries from the Okanagan Valley, British Columbia, are a popular treat during early summer months. A healthy diet includes dietary fiber from a variety of sources. The table represents the amount of fiber from various quantities of cherries. Okay, so here we got our chart here. There's just the three values in each column here. What we need to do, again, like I've done before, is identify right away what's independent, what's dependent. Okay, mass of the cherries, amount of fiber. Now, we are curious about getting fiber into our diet. And so the thing that we're going to be able to control is the mass of the cherries. What we're interested in is how that affects the amount of fiber we get. So this right here is independent. This is dependent. Okay, and again, that's important for how we answer some of these questions. Now, the first one here. Does the data represent a linear or non-linear relationship between fiber and the mass of the cherries? Okay, well, to be linear or non-linear, again, what we got to do here is establish a correspondence here. So here, when I go from one step to the next, I have been increasing 140 grams, 140 grams. Okay? Now, over here, I've increased by 3 grams, I've increased by 3 grams. So there is a proportional increase. Okay, when I increase this by a steady amount, I increase this by a steady amount. Okay, there's a direct relationship between them. So what we've got here is a linear relationship. This is linear. Okay, for every 140 gram increase in cherries, we get a 3 gram increase in fiber. Okay, that is a, whoa, I wrote on the wrong page. That is a linear relationship. Now, would the graph of this relation be continuous or discrete? Okay, well now this is an interesting question. Okay, and some of the other examples that we've done, the data's been all discrete here, but in this case, I believe this is continuous. Because we can subdivide the mass of the cherries and we can subdivide the amount of fiber that we get to whatever values we need. Okay, because this is mass. Mass is continuous. Now, that does not necessarily mean that our data is continuous. But I've got mass as an independent variable, mass as a dependent variable. So because both are continuous, okay, mass continuous, therefore the data is continuous. Now, that is not always true, because if I linked a continuous variable to one that was discrete, then the overall relation that I'm looking at here is discrete. It's going to be limited by the discrete variable. Okay, but in this case, the data is continuous because everything's here is continuous. Determine the slope of the graph. Okay, so slope, remember, is change in the dependent variable over the change in the independent variable. That's why that's why I needed to be clear right from the beginning which of these was dependent, which of these was independent. But now that we've decided that this is the dependent, this is the independent, let's pick 2 points here. Let's maybe pick the extreme 2 points here. So to go from this point to this point, I had an increase. Okay, well that's 12 minus 3, so that's an increase of 9. So this will be 9. And to go from 140 to 560, well, how much have I gone up by? Okay, well, 560, sorry, I should write that down here. 560 minus 140. Oops, can you see that? Is going to be, that was an increase of 420. Okay, now, just because I don't trust myself, there we go. And now, can we reduce that? I think we can. 420, does that divide by 9? Nope. But 420 will divide by 3. So I can divide both, and look, I get 3 over 140. Now notice that my units here would be grams over grams. So those cancel out here. So basically, this is simply a ratio. And this means we get 3 grams of fiber for every 140 grams of cherries. Now, determine the amount of fiber in 420 grams of cherries. Well, we just pointed out that this is the relationship here, right? This is fiber per grams of cherries here. So fiber, okay, if we use, let's say F for fiber, is going to equal this proportion here times the number of grams per, let's say, cherries. So we let C be the grams of cherries. So grams of fiber per grams of cherries multiplied by grams of cherries. So in this case here, I would write that the amount of fiber is going to equal 3 over 140. Okay, that's basically the slope of the line, or the ratio here. And then I will multiply that by, multiply that by 420. Okay, so 3 divided by 140 times 420, and I'm going to get 9 grams of fiber. Oh, there you go.